Here's the graph of y equals x, and we're going to consider the area of this triangle. Now the equation of the graph is y equals x, so the y number equals the x number, so instead of writing y there, I could write x. So the area of that graph is a half x squared, because the area of a triangle is half the base times the height. Let's think about another graph. Let's think about y equals 3x, and that area here. If this height here is x, if the length there is x and the height is 3x, so the area is a half of x times 3x, which is 3 halves x squared. So we can put our results in a table. Now it can be shown, although it's beyond the scope of A-level, it can be proved that if you've got the equation is y equals x squared, the area of the graph is a third x cubed. If you've got y equals 2x to the power 5, the area under the graph is 1/3 x to the power 6. Now a thrilling result is the fact that if you differentiate these expressions, you get those expressions. If you differentiate 3 halves x squared, you get 3x. If you differentiate the area under the graph, you get the equation of the graph. That's just a pause reflection for you to consider the beauty of maths. So to find the area under a graph, we need to do the inverse of differentiation, and the inverse of differentiation is called integration. So what function could we differentiate to get 2x? Well, it's x squared. What function could we differentiate to get 3x to the power 4? It's 3/5 x to the power 5. What function would we differentiate to get 5x to the power 7? It's 5/8 x to the power 8. Notice that to check, we need to go this way. So going this way, we're differentiating. Going this way is integrating. So this is integrating. This way is differentiating. So remember, how do we differentiate? We do 8 times 5/8. The 8's cancel, so that leaves the 5, and the power reduces by 1 to make 7. So to get a formula for this, we would need to have ax to the power n. So the power increases by 1. Let's get this right, there we go. And you divide by that power, by that n plus 1. Now there's a slightly obscure notation that you need to remember, because this is going to become very familiar to you over the next 2 years of the course. To work out the area under the graph, firstly consider a tiny rectangle like this, and the width of this rectangle is going to be a very small increase in x, and that's often written as delta x. The height is y. Now if you imagine getting the area of that rectangle, it's y times delta x. And if you then imagine adding up all the rectangles that were like that, we'd use the sigma sign. Now the smaller delta x is, the smaller the width, the more the better this approximation is to the area. And so what happens is that the sigma sign, which is this one, the sigma sign, which sigma starts with the letter S, and the first letter of the word sum is S, so there's an elongated S that's written to show that it's the sum of all the y numbers multiplied by the x numbers, so it's y dx. So this is a formula for the area under a curve, and it's the integral of y dx. So here's another example. Let's integrate 4x to the power 7 with respect to x. Remember, the power increases by 1, and then you divide by that increased power, so it's 4/8 x. 4/8 x is x to the power 8 is obviously a half x to the power 8. That's because if we differentiate 1/2 x to the power 8, we get 8 halves, which is 4 x to the power 7. But notice, if we differentiated 1/2 x to the power 8 plus 4, we'd also get 4x to the power 7, because 4 differentiates to nothing. It doesn't have to be 4, it could be anything. That could be 5, it could be 3, it could be anything. So what we really need to say is there could be some number in there, some constant number. It wouldn't be a letter, it doesn't involve x, a constant number, let's call it c, and if I were to differentiate that constant number, it would go to 0. So that means at the end of this answer here I should write plus c. C is a constant of integration. Now in your maths exams there's always 1 mark for writing in the plus c. In other words, there's a very easy way to lose a mark, and that's to forget to put plus c in. But having seen this video and having seen it in red, you won't forget, you'll remember that plus c goes at the end of any integration.